Alright, time for another draftphysics.com and debatephysics.com video presentation. The Ian Gosling guy has made another video trying to fake a result to defend a theory that can't be defended. It's absolute nonsense. And they just keep doing this. And he's just so stupid. So I think I'll put this video in the category of momentum versus VMV, kinetic energy. But it could go in the gravity category also. So, choice I'll have to make. And it regards this idea of, that somehow, when something falls in gravity, if it falls a longer distance, that somehow it gains momentum or force or energy from gravity per a unit of distance, when clearly it's 9.8 meters per second per 1 second. So every 1 second you get a certain amount of force, and it's a time dependent force, and I've provided so many examples proving that. Now Galileo proved it hundreds of years ago, and that's this physics they're basically attempting to evade and deny. And why I just can't imagine why anybody would not recognize that the truth is just kind of obvious. So there's all kinds of ways you can illustrate it, but we'll use this example first. So you drop the same weight from 1 unit of distance, and it has a certain impact weight, you could say. A certain amount of energy. It's going to make a certain amount of pressure on the ground. And the simple truth is that I drop the same weight from 4 times the height. This portion of the event is going to be exactly the same, right? Let's just say it takes a second to drop this distance. So you know that's 9.8 meters of velocity it's going to have when it hits here. And you know that this is 9.8 meters of velocity here. This will take 1 unit of time. This is 1 unit of time, 1 second, 1 second. All right. And we know these as absolute facts. And so their argument is in the second of gravity, which will be this whole distance, even though it only gained 9.8, that is, it's only 19.6 when it hits here. It only got 9.8 in this whole distance, and it only took 1 second. It's the same amount of time, all right? And clearly, half the velocity is here. It reaches 1/2 the velocity here, after just doing this. So obviously that's 1 unit of energy, and somehow it got 3 units of energy here? No, it didn't. It only got 1. This is only twice the weight, okay? This is 1 weight. This is twice the weight, okay? Twice the force, twice the pressure. Nothing more. So then you roll something, okay? And so this is basically the experiment he's doing, except he's rolling it on an internal bearing. So he's got an internal bearing rather than a road bearing. All right, but it's exactly the same experiment. You got exactly the same results, which is, ironic. Okay. All right. So if I roll it with twice the velocity, it will go 4 times the distance. But again, it's exactly the same argument. It's going to do exactly this. 1 velocity, 3/4 of the way down the track. That's the truth of it. All right. And so and again, it's going to be the same time issue. This will be 1 unit of time. This is 1 unit of time. This will only be 1 unit of time also. So this is 1 unit of time. This is 1 unit of time. Same amount of time to do this whole thing here as it will take to do this thing here. 1/2 the velocity right here. Okay, 3/4 of the way down the track. Obviously, if it was linear friction, it would go half the velocity halfway down the track. Okay, so no other way it can happen. So you know this is 1 unit of energy. You know this is 1 unit of energy. And somehow your argument is that it did 3 times the work here. And it's just nonsense. It didn't. Obviously, the friction is about how long you're in the gravity. You're in the gravity for 1 unit of time, the same amount of time you were in the gravity here. It's the same force pushing you into the surface, same amount of force over this 3 as happened here, same force. If 3 units of force hit here, then it's 3 units of force here, because it's the same exact amount of time having gravity pushed down on the object. The same weight was applied to this ground as was applied to this ground in total. So if you add up the amount of pressure, there was the same pressure over this large surface, the same amount of paint hit this large surface as hit this small surface. It's all so obvious. Now I could draw planets and I could just make the argument that the faster I go across a gravitational field, the less I'm going to get bent, and the slower I go, the more I'm going to get bent. Why? Because it's a time-dependent force. It happens in units of time, not units of distance. And then I could have something heading for the Earth, and I could point out that if I gave this a velocity going into the Earth, that it would only do this distance in much less time, 1/10 of the time, let's say, that something else would fall, and that those two things will gain so much different in terms of a change in their velocity because of how fast they go through the gravity. So the faster you go through a gravitational field, the less you're going to get out of it. And the slower you go through a gravitational field, the more you're going to get out of it. It's just like a paint sprayer. It's just like the inverse square law. It's just like photons hitting you. The longer you're in the sun, the more suntan you get. It doesn't matter how much moving around you do. It just matters about how much time you're being exposed to the force. That decides how many ions are going to be created. Just a fact. And so it's just so absolutely true. And they keep arguing as if something else could possibly be true, and there's no other possible truth. All right, so I'll erase this and just draw his silly experiment. But his silly experiment is just this experiment. He's just doing the same experiment over again, and reiterating a point that is pointless because it's just absolutely wrong. All right, so I'll play the beginning of his video just because it's funny that he doesn't understand how friction works at all. Just has no clue. So he's spinning a wheel, all right, on a bearing, okay, and so he's giving it a rotation. So he doubles the speed of the rotation. So he spins it once, and then he spins it a second time with twice the speed, okay, 2x the speed. And he argues that this spins 4 times as many revolutions. But it only takes twice the time, okay, exactly twice the time actually in his experiment. So it takes only twice the time, even though it's supposed to have 4 times the energy. It only spins twice as long, okay. It doesn't spin 4 times as long. All right, just spins 4 times as many times because again, what is he says, let's do it without friction. Well, what do you mean? You're spinning it until it stops. What's stopping it? If it's not friction, what causes the wheel to stop spinning? Of course it's just friction. All you're doing is changing the point that you have the friction from the top of this bearing, right? The bearing's sitting on, it's being pushed down. The wheel's being pushed down on the axle, and so there's a friction on the bearing. So you're just changing where the friction is. Instead of the friction being against the road, it's against this little bearing surface. But it's the same gravity-controlled friction. So again, in this case, you're only being affected by the gravity twice the time that you're affected by the gravity in the other case. And the simple truth is there's less friction per rotation when you're going faster. The faster you go, the more distance you can travel in the same amount of pressure being applied to the bearing. So so per linear foot, it's less friction the faster you go, and it's more friction the slower you go. And the key thing is that when this speed, let's say this was 25, okay, revolutions, okay, and this was 50 revolutions. The key moment is when it hits 25, it's gone 3/4 of the way down the track, okay? It's 3/4 of the time has been expended. So again, it doesn't go half the speed at half the time. It goes half the speed after it's traveled. It's done 70. Let's say it does 100 revolutions. Well, no, it's 50. No, it does 100. It doesn't, it does 100 revolutions, and this does 25 revolutions before it stops. It starts going exactly the same speed as this one started at after 75 revolutions. So it goes 75 revolutions, and then it goes one velocity, or 25 revolutions. So it starts at 50. It ends up going 25 revolutions after it's traveled 75 revolutions. So it's exactly the same 1, 3, 5, 7. Again, this is Galilean physics. Well established as facts, and they just keep trying to deny it. So now the simple thing you could do, instead of claiming there's no friction, which is idiotic, is create a friction source that's not gravitational. So you could put a little playing card on here, like kids used to do with their bicycles. You put a little playing card, have it click every time, so it has to flip the card every time it goes around. Now that would be non-gravitational friction. Okay, it would be taking the energy in equal clumps that isn't dependent on gravity or time, and it's just a unit of pressure applied to a card. And when he did that in the original case, so he did this experiment a month ago, and what he had done is put a brush on the axle. So as the axle spun, it had a brush on it, so the brush was slowing the axle down. So again, it's a non-gravitational extraction of the energy. And of course he didn't get this 4 times the distance thing. Didn't happen because it wasn't time dependent force. It was an absolute take your energy force that didn't matter about how long. It just mattered about how much you moved something. It didn't matter how much time you took to do it. So it wasn't a gravitationally controlled friction. It was a friction of some other kind, okay, that doesn't play by gravity's time dependent rules. And that's the simple truth of it. So we'll play. I just can't believe I have to argue this with people that are supposed to have some kind of brain. They're supposed to be thinking and, about how things work, or be engineers even. I mean, this dope might even call himself an engineer, and he can't figure out that obviously if the wheel stops spinning, it's not frictionless. Obviously. Really stupid. So, we just go to the beginning where he says all of that kind of crap.
Hello, guys. I thought I'd do this test again. I wanted to disprove Gary's idea that...
Okay, so he's doing the test again with... Before he complained that the reason why he couldn't do the experiment by just spinning the wheel, again, which is just like rolling it. There's no difference. He's just placing the friction at a different point. Instead of the friction being on the bottom of the wheel, he's just changed the location to this little bearing. So he hasn't changed the experiment at all, in the sense it's still all being controlled by gravity. If there was no gravity, the bearing would have very little friction, and it would spin perhaps days. Who knows how long it would spin if you put it in space, because the bearing wouldn't have any bearing points, and everything would just kind of spin without touching anything else. It would get to an equilibrium point, and it would spin a really long time if placed out of gravity. And the fact is, the only thing that makes the bearing inefficient is the fact that gravity is pushing metal against metal.
The wheel rolling on the ground only goes 4 times as far from twice the speed.
Only goes. Yeah, no, that's the surprising part. Yes, it goes 4 times as far, but it only takes twice as long for it to run out of gas. Only twice as long.
Because it's a reduction in the friction on the ground.
Yes, the faster you go, the less weight you put on the ground. So this is, again, these people will argue that you can't physically slide across thin ice, that it won't work, that you have to fall through thin ice. You can't possibly slide across the ice quickly and not fall in. You have to fall in because it's the same distance, it's the same force. Therefore, per foot, it's always the same weight, and you have to fall in. That's their argument. It's that stupid. And I have to make these videos on the internet, in public. This is the state of the defenders of science. This is how bad the arguments are. And the physicists won't show up and say, oh yeah, you're right, that experiment's a pile of shit. They won't show up and do a damn thing. You know, they won't take any responsibility for the silly notions they've put in these retards' heads. So they've hyped up all this bullshit, the most proven theory in the history of mankind, all of this hype. And now they have these frickin' morons believing this nonsense.
I was going to make a ramp and roll this down, attached to strings.
And how would that demonstrate how much energy it is? Again, you have to extract the energy with some method, okay, that's reliable, that tells you how much, like say if it was heat, you measure how much heat is coming off the surface per unit of time. You have to measure it in some kind of quantity that you can pull off, that you can actually measure. It has to be a measurable device. You know, not one where you just look at it and say, well, it looks like. Well, you know, again, now we're back to the ice again. It looks like what? Magic? Because I can slide across thin ice? That's now magic? No, it's understandable. I'm placing less weight per linear unit of distance on the surface. And therefore, the surface doesn't break because it has less weight on it.
And then have it swing off the ramp and spin on the bearing. And I thought there's no need to do that. Do away with the ramp. Just do this. And I'll do 2 speeds, 100 RPM, 200 RPM. And I'll count the revolutions. Because
I don't know what exactly he's counting with, but it doesn't look like those numbers. But it doesn't really matter. They're consistent enough.
it's this business about the friction, the reduction in friction, making the wheel go 4 times as far.
It's not, so he kept seeing the reduction in friction, making it go 4 times as far. This is all very inarticulate stated. The point is that gravity's creating the friction. Without gravity, there'd be no friction. The contact has to be, something has to push the wheel into the ground. If nothing pushes the wheel in the ground, it doesn't touch the ground. It doesn't lose any energy. You don't get it? All right, there has to be some force that's obliging there to be contact, and the contact just means that you're going to take the energy that's in the wheel and you're going to put it into the ground. And the simple truth is the slower the wheel's moving, the firmer the contact with the ground and the more energy it loses to the ground per inch. It's just a fact. Because it's better contact. I equated it to electricity. It's like having a weak conductor and then a very strong conductor. You're pressing a wire just a little bit, touching, and only a certain amount of watts can go through. But if you ram the wire in there, then all the wattage can go through.
Let's do away with the friction.
So he says, so there's nothing else to slow the wheel down. I mean, air resistance is minimal. So if it was just air resistance and there was no gravity, then this thing would spin for a very, very long time.
Completely. Let's make that.
So, and it would spin at exactly twice the speed, right? So if it could roll things in space, something going twice the speed would go twice as far because it's going twice the speed, because I wouldn't be extracting any of its energy. The whole point is the friction's extracting the energy. That's what you're supposed to be measuring, is how much actual energy went into the ground. And the fact is that the 4 times the distance, it's still only twice the time and the gravity, and it's still only twice the weight on the ground. The ground only felt twice the weight, 2 units of gravity.
A non-issue. We've got it on a very nice bearing there.
So he's calling friction a non-issue when, of course, it is completely being controlled by the friction in the bearing. That's where the energy goes. There's nowhere else for it to go except to air resistance. Like I said, if you depend on air resistance, it would take, an hour for it to stop spinning. All right, so there's just really no point, but I'll tell you the numbers came out exactly. Okay, so I had written them down, but it was 110 seconds for the slow one is 55 seconds, and twice the speed was exactly 110 seconds. So it came out exactly, and at 3/4 of the time, okay, I mean half the time, at half the time, the wasn't half, yeah, half the time was where half the velocity was, not half the distance. So it was after 70 rotations. Let's say the one twice the speed rotated 70 times, and the one rotating at one velocity rotated 25 times. At 75 rotations is when the second wheel, going twice as fast, was going exactly the same speed as the first wheel started at. So that's all demonstratable. You could watch the video and do your own counting of the time, and you'll find that's exactly the truth. So it perfectly illustrated exactly what happens when you roll an object. Came out exactly the same, demonstrating that Galileo was right, demonstrating that yes, you can go across a surface quickly and apply less weight to the surface and not fall through the ice. I mean, again, to sit there and say that I have to argue the fact that you can slide across thin ice quickly and not fall in, to have to defend that as a truth in America in 2023 or 24, it seems idiotic, right? That nobody in the English-speaking world should have to have that explained to them, that you can slide across thin ice quickly and not fall through. To have to explain that to anyone over the age of 7, you would think would be an impossibility, that anybody has to have that explained to them. But these people do. Physicists need that explained to them, because they're going to tell you friction is linear when it's obviously not. It's completely time dependent. Doesn't care about distance, cares about time. How much time you're in a paint spray, how much time you're in the sun, how much time gravity is working on you. All the same thing. And I can't believe I can't get people to say, yeah, that needs to be fixed. If physics is saying I can't slide across thin ice, then physics is broken. Physics has it's it's got a hemorrhoid. It's got something wrong with it. Okay, it's broken if it thinks that's the truth. I can't slide across thin ice. Bullshit, I can't. All right, I got enough of a video, I guess. Just so disappointing that people are this stupid. And it's belligerently. I mean, again, I said I wasn't going to bother with this guy, blah, blah, blah. He hadn't made a video in 2 weeks, so I said, okay, what the hell, I'll watch this piece of shit. And he's just doing the same thing, same bullshit title. Double the velocity, 4 times the energy. Where did you measure the energy? Where did you measure how hot the bearing got? Did you do that? No, you didn't do it. You didn't measure energy anywhere. You're just such an idiot. You're such a liar. You're such a piece of garbage as a human being. And you're really, really fucking stupid. Again, he's doing all this to try to prove that you can't move fast across thin ice and not fall through. It's impossible. Because it's the same pressure on the ice. Doesn't matter how fast you go. Same pressure on the ice. That's what they're saying. You have to believe because their theory's right. When obviously it's wrong. Fuck. No, it's just so depressing. Just, ugh. I just hate this planet of stupid motherfuckers. Damn.